So, welcome everyone. Today we will study composite numerical integration. So, up till now we have done with numerical integration. So, we have seen Newton's Cotes quadratic formula, and in that we have derived the various formula of trapezoidal rule, Simpson's 1/3 and 3/8 rule, and Wedel's rule. Okay, so now we will go with the composite numerical integration. Okay, so first we will study that the composite trapezoidal rule. Okay. So let's suppose there is a curve like this, and you have to find the area of this curve. Okay. This is f of x. This is between f of x or which is equal to 1. Okay, and it is x. Okay. So first point is x naught. Okay. Then second is x1. Then is x2, x3, x4. This point is x5. Okay. We are dividing this area into small segments, okay, from x0 to x1, x2 to x3, x3 to x4, x5, and x5. So this x5 is, let's suppose this is xn, last one, okay. So to improve the accuracy of the trapezoidal rule, so why we are using increase the accuracy of the trapezoidal rule. So we study the composite trapezoidal rule. Okay, so to improve the accuracy is the main. So we are dividing the integration from A to B. Okay, so this is A to B. So we have to find I is equal to integration from A to B f of x dx. Okay. So it is our aim to find the integration from starting point to the last point. It is integrated from A to B, and what is this? It is f of x. Okay, f of x into dx. So we have studied trapezoidal rule in previous lecture. And now, in order to increase its accuracy, to get more accurate result, we go with composite trapezoidal rule. So what we have done, we have taken these points, okay, this, and distance between this is h, okay, and h is equal to b minus a divided by n. Okay, so this is for equally spaced values of x. Okay, so h is equal to b minus a divided by number of the subintervals. Okay, so now we will find area of these individual segments. Okay, and then we will add these areas and we will get the total integration. I is equal to integration a to b f of x dx. Okay. So total integration I. So this can be written as from a to b. So what we are doing, we are integrating this term. Okay. Okay, so we will find the area under this curve. Okay, so with the value of x is x naught to x1. So this will be from x naught to x1 f of x dx. Okay, plus the second one from x1 to x2. From x1 to x2 f of x dx. Okay, so in this way we can find the values. Okay, so this can go up to n terms. So this is from xn minus 1 f of xn into dx. Okay, so what we are doing, we are dividing this curve into n number of segments. Okay, this is first, second, third, and up to n segments. Okay, and we are finding the area of each segment. Okay, so this will be from x0 to x1. First, x0 to x1 f of x dx. Then x1 to x2 f of x into dx. Okay, integration. And then this is nothing. This is n minus 1. Last term n minus 1. Okay, so we will get the integration. Okay, substituting the trapezoidal rule for each value. So if you substitute the values here, so this will give this will be f of x naught plus f of x1 divided by 2 into h plus h into f of x1 plus f of x2 divided by 2. Okay. Plus, so I will be equal to plus last term h f of x n minus 1 plus f of n divided by 2. Okay, so this will be the last term. So grouping this term, we get h by 2 f of x naught, this is the initial value, plus 2 f of xi, and I is from 1 to n, plus f of xn. Okay, n minus 1, this is n, this is n minus 1. Okay, so this is nothing, this is equation of composite trapezoidal, formula of composite trapezoidal. Okay, h upon 2 f of x naught plus 2 in summation I is equal to 1 up to n minus 1. This is not n, so I is extending from 1 to n minus 1 f of xi plus f of xn. Okay, so this can be written as, so h can be written as b minus a. Okay, and this is f of x naught plus twice summation I is equal to 1 from n minus 1 f of xi plus f of xn. Okay, so this is width. This is width. Okay, and this is height. So area is width into height. Okay, so in this way, this is average height. Okay, so we are getting the integration. Okay. So you have to remember this formula. Okay. And what about error? Error in this case, so error is given by EA is equal to minus B by A whole square. Is upper limit, is lower limit, and upon 12 n square. N is number of subintervals f double dash. Okay, so you have to integrate the given function f double dash. Okay. So this is the error in case of trapezoidal. Okay. So now we'll take one numerical, one problem based on this. Okay. And then we see composite trapezoidal Simpson rule. Okay. So use the two segments. Okay, so it is given you have to use two segment. So what do you mean by this two segment? We are taking only two areas. So value of n will be 2. Okay, so two segment means value of n is equal to 2. Okay, two segment trapezoidal rule. To estimate the integral of, so you have to find integral of this f of x is equal to 0.2 plus 25x minus 200x square plus 675 x cube minus 900 x to the power 4 plus 400 x to the power 5. Okay, from a is equal to 0 to b is equal to 0.8. Okay. So, so you have to find the integration. I is equal to integration from a to b. A is 0 and b is 0.8. F of x into dx, where f of x is this much using two segment trapezoidal rule. Okay. So now we have to apply this formula. Okay. So according to composite trapezoidal rule, we have this formula. Okay, so we have to find what will be the value of n and I. So it is in the question. It is given n is equal to 2. Okay, n is equal to 2 from here. If it is 3 segment, then n will be 3. 4 segment, n will be 4. Okay, so we are dividing this area into 2 segment only. Okay, so this curve is like this. So it is divided into 2 segments. Okay, so x0 will be 0, x1 will be 0.4, and x2 will be 0.8. Okay, so first we find the area of this segment, and then we will find the area of this segment, and then we add it. Okay, so this is composite trapezoidal rule. Okay, so h, how to calculate h? H is quite clear. It is, we have to divide into 2 segments. So this is b minus a divided by n. Okay, so b is 0.8 and a is 0 divided by n is 2. So this is 0.4. So h is 0.4. Okay, so now here when n is equal to 2, okay, so I will be equal to h upon 2. This is f of x naught plus twice integration I is equal to 1, n is 2. This is 2 minus 1, f of xi plus f of xn. Okay, so this will be, so xn, n is 2, so this will be x2. Okay, so h by 2, f of x naught plus twice. So n minus 2, so this will become 1. Summation I is equal to 1 se likha 1. So f of xi plus f of x2. Okay, so this will be h upon 2 f of x naught plus twice. So this is only value of x is 1. So this is f of x1 plus f of x2. Okay, so this will be the value of I. Okay, so this is the formula h upon 2 f of x naught plus 2 summation I is equal to 1 up to n minus 1 f of xi plus f of xn. Okay, so here n is equal to 2, so this is 2 minus 1 and this is x2. So 2 minus 1 is 1. So I, the value of I is actually from 1. Value of I is only 1, so this will be x1. Okay, so the function is this. So f of x is this much. So what you need, x naught. So f of x naught will be equal to when x is equal to 0. So this will be 0.2 plus 0. So this will be minus 0 plus 0 plus 0 plus 0. Okay, because value of x is 0. So f of x0 is 0.2. Then f of x1. Okay, so when x is equal to 1. Okay, so 0.2 plus 25 into 1 minus 200 into 1 square plus 675 1 cube minus 900 1 to the power 4 plus 400 1 to the power 5. Okay, so on solving this, here, sorry, when x is equal to h, we have to take h. Okay, so this will be 0.4, 0.4, 0.4 cube, 0.4 cube, and sorry 5. This is 0.4. Okay. So f of x1 is 0.4. So this is f of 0.4 will be equal to 2.456. Okay. Then similarly, f of x2 will be f of 0.8. Okay, so this is f of x1, this is f of x2. Okay, so we have taken h is equal to 0.4. So x naught will be equal to 0, then x1 will be 0.4 and x2 will be equal to 0.8. Okay, so this will be equal to, we have to substitute, so 0.2 plus 25 into 0.8 minus 200 into 0.8 whole square plus 675 into 0.8 whole cube minus 900 into 0.8 to the power 4 plus 400 into 0.8 to the power 5. Okay, so on solving this, the value of f of 0.8 is 0.232. Now substitute this value, this value, this value, and this value. Okay. So this will be equal to, value of h is 0.4 divided by 2. F of x naught is 0.2 plus twice of f of x1. This is f of x1 is twice 2.456 plus f of x2 is 0.23. Okay. So on solving this, we get 1.0688. Okay. So this is how you have to calculate the composite trapezoidal rule. Okay. So this is the formula: I is equal to h upon 2 f of x naught plus 2 summation I is equal to 1 n minus 1 f of xi plus f of xn. Okay. So here n is equal to 2, so this will be 1. So from 1 to 1, and this is x2. Okay. So this will be x naught 2 into x1 plus f of x2. We have to find x naught, x1 and x2. Okay. So value of a and b is from a is equal to 0 and b is equal to 0.8. Okay. And number of sub-interval is equal to 2. So this will be 0.8 divided by 2. So h will be equal to 0.4. So value of h is 0.4, x naught will be 0, x1 will be 0.4 and x2 is 0.8. So substitute here. So f of x naught is f of 0. Okay. So this is f of x0 is equal to 0.2. Substitute x is equal to 0. Then f of x1 is f of 0.4. Okay. So substitute x is equal to 0.4. Then f of x2, that is f of 0.8. So substitute the value of x as 0.8. So you will get f x naught, f of x1 and f of x2. Okay. So substitute here. Substitute the values. So this is x naught, this is x1 and this is x2. Okay. On substituting this, you will find the value of integration. So value of the area of this curve is 1.086. Okay. So any doubt? Okay. So now we move towards the composite Simpson, sorry, 1/3. गाड़ी के लिए आपको कैसे Okay. So next topic is composite Simpson's. Okay. So why we are studying this composite rule? Because to improve the accuracy of this Simpson rule. Okay. So accuracy of this method, Simpson rule, can be improved by using this composite Simpson's rule, 1/3 rule. Okay, Simpson's 1/3 rule. Okay. So again, we are taking a loop. Okay. So first is x naught. So again, we will divide into small segments. Okay, and then we will find the area of these n minus 1 xn. Okay, it is a and it is b. Okay, so this is f of x and this is x. So you have to find the integration I is equal to from a to b f of x dx. Okay. So again, we will divide this curve into different integrals as for different segments. Okay. So this is divided into different segments. Like this. So we have divided into equal. So Simpson's rule can be improved by dividing the integration integral into number of segment of equal width. Okay. So how we can improve the Simpson rule? By dividing the integration integral into number of segment of equal width. So this width is equal. Okay, so this is h. So h is equal to b minus a divided by n. So all are having equal widths. Okay, so this formula is applicable for equi-spaced or equal interval of this argument is x. Okay, so why we are using this composite Simpson rule? So to improve the accuracy of Simpson's 1/3 rule, so we have divided into small segments of equal width. Okay, so total integral represent. So in Simpson's rule, we have taken n is equal to 2 or even multiples. Okay, so the total integral I will be from 0 to x2. Okay, f of x dx plus x2 to x4 f of x dx plus that of 2 f of xn minus 2 x dx. Okay, so it is from x0 to x2, x2 to x2, x4, x4 to x6 and so on. Okay, so this is the case. So this is first integral, then second integral and so on. Okay, so you have to recall the Simpson's 1/3 rule. Okay, so substituting 1/3 rule for each integral. So I is equal to h substituting Simpson's 1/3 rule to each integral. Okay, so we are substituting the values of substituting Simpson's 1/3 to each integrals. Okay, so this will be h by f of x naught plus 4 f of x1 plus f of x2 divided by 6 plus 2 by h f of x2 plus 4 times, so 4 times the odd terms f of x3 plus f of x4. Okay, so this is initial term, this is last term. Okay, divided by 6 plus l dash of 2h, so this is f of x n minus 2 plus 4 times f of x n minus 1 plus f of x n whole divided by 6. So I is equal to h by 3 f of x naught plus 2 summation I is equal to 1 n by 2 minus 1 f of x2 I plus 4 times I is equal to 1 n by 2 f of x 2I minus 1. Okay, so this is general equation of composite Simpson's rule. Okay, so this is h upon 3 f of x naught plus 2 summation I is equal to 1, so n by 2, so this should be n is equal to even integral only. Value of it is, we know that value of n should be even multiple. Okay, so f of x 2I plus 4 I is equal to 1 n by 2 f of x 2I minus 1. Okay, so this is the general formula of composite Simpson rule. Okay, so we will solve the same problem. Okay, okay. So use composite Simpson's 1/3 rule to find integral, to estimate integral of same f of x is equal to 0.2 plus 25x minus 2200 x square plus 675 x cube minus 900 x to the power 4 plus 400 x to the power 5. Okay, from value of a is equal to 0 to value of a is equal to 0.8. Again, the value of a is equal to 0 and b is 0. B is equal to 0.8. Okay. And here, in question it is given, take n is equal to 4. Okay. So if it is not given in the question, you have to take the value of n which is even. Okay. So this is the equation, and when n is equal to 4, this will be h upon 3 f of x naught plus 2 integration I is equal to 1. So this is 4 by 2 is 2, 2 minus 1 is 1. So this will be 1 f of x2I plus 4 times summation I is equal to 1. N is 4, 4 divided by 2 is 2 f of x2I minus 1. Okay, so first what we have to do, we have to write this formula. So this is Simpson's composite Simpson's rule. Okay, so you have to remember. Okay, so this is h by 3 f of x naught plus 2 summation I is equal to 1 n by 2 minus 1 f of x 2I plus 4 summation I is equal to 1 n by 2 f of x 2I. This is 2I. Okay. 2 into I minus 1. So we have substituted n is equal to 4. So 4 divided by 2 is 2, 2 minus 1 is 1. 4 divided by 2 is 2. Okay, so we will get this formula. So we have to elaborate this formula. Okay, so what we will get? So this I will be equal to h upon 3 f of x naught plus summation from I to I is equal to 1 to 1. So this will be 2 f I is equal to 1. So this will be x2. Okay, plus 4 times. So first I is equal to 1, we have to put I is equal to 1. So this is 2 into 1, 1. 2 minus 1 is 1. So this will be f of x1 plus, we have to put I is equal to 2. So this will be I is equal to 1 and 2. So 2 into 2 is 4, 4 minus 1 is 3. So f of x. Okay, like this. So what we have done, we are elaborating this equation. So this is summation I is equal to 1. So there is only one value of I. So this will become 2 into 1. So this is x2. Here I is extending from 1 to 2. So first we have to put I is equal to 1. So 2 into 1 is 1. 1 minus 2 minus 1 is 1. So this is x1. Second value of I is 2. So 2 into 2 is 4. 4 minus 1 is 3. x3. Okay. So now we have to find the plus xn. Forget to write plus xn. So plus last term f of xn. Okay. So here value of n is 4. So this will be plus f of x4. Okay, so when n is equal to 4 and we have elaborated this summation, so now we know that the various values of f. Okay. So f naught, f0 is 0.2, f of 0.2 is equal to 1.288, f of 0.04, so this is 2.456, f of 0.6 will be equal to 3.464 plus f of 0.8 is equal to 0.23. Okay. So here n is equal to 4. So we have to calculate the value of h. Okay. So value of h will be equal to b minus a divided by n. So B is 0.8 minus A is 0 divided by N is 4. So this will be 0.2. Okay, so value of H is 0.2. Now we have to find f of x naught, x2, x1, x3 and x4. Okay, so the value of x naught will be equal to 0, x1 will be 0.2, x2 is 0.4, x3 is 0.6 and x4 is 0.8. Okay, so in this way we have divided various interval, 4 interval. X naught is 0, x1 is 0.2, x2 is 0.4, x3 is 0.6 and x4 is 0.8. Okay, so we have to find, so I have written earlier, so f of 0, it is f of x0. So we have to substitute x is equal to 0 in this equation. So this will be 0.2. Okay. Then f of 0.2, that is f of x1. So we have to substitute value of x. So this will be 0.2 plus 25 into 0.2 whole square minus 200 into 0.2 whole square plus 675 into 0.2 whole cube plus minus 900 0.2 whole to the power 4 plus 400 0.2 whole to the power 5. Okay, so in this way you will get the value 1.2. Okay, so now for f of 0.4, this is f of x2. So how will you find this 0.4? So you will substitute in place of x 0.4. Okay, so you will get f of 0.4 is 2.546 and f of 6, that is f of x3. So substitute the value of x as 0.6 and for f of 0.8 substitute the value of x as 0.8 and you will get respective values. Okay, so now we'll substitute these values here. Okay. So this is equal to h is 0.2 divided by 3. F of x naught is 2 plus twice f of x2. F of x2 is this. This is f of x1. This is f of x2. This is 2.456 into 2 plus 4 times f of x1. F of x1 is 1.28 plus f of x3. This is f of x3. This is 3.464 plus f of x3. Sorry, f of x4. This is f of x4. So 0.23. So on solving this, you will get 1.623467. Okay. So value of I. So we have integrate the same value in case of trapezoidal. It is I is equal to 1.0. 1.688. So this is from Simpson's 1/3 rule composite, and this value is from Trapezoidal. Okay, and exact value is the exact value is 1.64053. Okay, so you can see that the value of I using trapezoidal rule is 1.068 and value of I using Simpson's 1/3 rule is 1.6234. Okay, and the exact value of I is this much, 1.643. So what we can conclude from this deduction, that Simpson's 1/3 rule giving more accurate answer result with in respect to trapezoidal rule, composite trapezoidal. So you can find the error. Okay, this minus this percentage error divided by true value minus calculated value divided by. Okay, so this is the true value, exact value is 1.64 and we are getting 1.623 by using Simpson's 1/3 rule, and by using trapezoidal rule we are finding I value of I is 1.688. Okay, so this is all about composite numerical integration. Okay, any doubt? Okay. Thank you, class.